Welcome back. We are on Unit 6 of our ACT Prep, Plane Geometry. And today we're going to talk about concept of proof and proof techniques. All right, so the concept of proof and proof techniques. Proof means using what is known in a logically convincing way to establish that a hypothesis is true or false. Much of geometry involves proving or disproving hypotheses. Consider this simple example. You're given that one angle of a triangle measures 90 degrees, while another angle measures 50. The sum of the measures of the angles in a triangle is 180. So you can start off saying, well, my hypotenuse is that the third angle in the triangle measures 40 degrees. And, my proof is that the 90-degree angle they gave me plus the 50-degree angle they gave me equals 140 degrees. This little piece of information tells me that the sum of the measures of the angles in a triangle is 180. That would be given. So I can say that the third angle is 180, take away 140, which is 40 degrees. Okay, so the proof uses only what is known and is logical. Some theorems that we're going to use prove that showing triangles are congruent. So we use side, 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 angle, side angle, and side angle, side congruence relations between triangles to prove that triangles are congruent. So we have three laws that allow us to confirm or deny that two triangles are congruent. One says that if, this is the side, side, side theorem, if each side of one triangle is congruent to the corresponding sides of another triangle, then the two triangles are congruent. Which means if you can prove the three sides in one are congruent to the three sides of the other, then the triangles have to be congruent. And congruent means it's not like similar triangles. Similar means that they have the same shape, but not necessarily the same size. Congruent means that they're exactly equal. They have the same shape and the same size. For angle, side, angle, it says in a triangle, if two angles and the side between them, that's important. The side has to be between the two angles that you know are congruent. But if the two angles and the side between them are congruent to the corresponding angles inside of another, then the two triangles are congruent. And the third one is side angle side. It says in a triangle, if two sides and the angle between them, again, the angle has to be between the two sides, them are congruent to the corresponding sides and angle of another one, then the two triangles are congruent. Okay, so this one, an example says you're given that the side, side, side congruence relation between two triangles. If each side of one triangle is congruent to the corresponding sides of another, then the two triangles are congruent. And then 2, you're also given the dimensions of the two triangles. And 3, you're also told that by the Pythagorean theorem, that in a right triangle, the sum of the squares of the legs, A and B, equals the square of the hypotenuse. So A squared plus B squared equals C squared. So my hypothesis is that ABC is congruent to DEF. And all I have to do is basically show that the three sides are equal, and I can use this theorem to say, therefore, the triangles are congruent. So what we're going to try and do is prove that this side is 5. If I can prove this side is 5, then I can prove that corresponding sides are equal, which means the two triangles are. So all I have to do is use what's given. From the diagram, I'm given that AB is equal to DE because they're both 4. And I'm also given that BC equals EF. Again, by the diagram. So that's given. We can also say that because of the Pythagorean theorem, which has been proven, I can say that in this triangle, that EF squared plus D, in other words, leg squared plus leg squared equals hypotenuse squared. So I have 3 squared plus 4 squared equals hypotenuse squared. That's 9 plus 16, which is 25. Square root both sides, and you get DF equals 5. So then I can say that DF and AC are both 5 units long. So now I can say that DF is equal to AC. And now I can say, therefore, the triangles are congruent by the side, side, side theorem. Okay? And the proof uses only what is known and logically shows that the two triangles are congruent by side, side, side. You could have also done side, angle, side. because you know this side is congruent to this side, this angle is congruent to this angle, and this side is congruent to that side. Okay, so here's a more formal way to present this proof. Okay, it presents each step in the proof and gives the reason for that step. So it says, my hypothesis was that triangle ABC is congruent to triangle DEF. And I erased the picture there, sorry. But again, I can say that AB equals DE, and BC equals EF, and AC equals 5, and all of those things are because that was given to me, okay? So then I can say, by Pythagorean theorem, that, again, just like I did before, but I'm putting it in this formal little box thing. So the next thing I did was try and find the side of DF, which I proved by Pythagorean theorem. And then I could say that AC equals DF. These two sides are both 4 or 5 units long. And so then I can say that the side, side, side. And so since 3 sides of my triangle are congruent, I can say well, obviously that's reason because they have equal length, so they're congruent. And then I can say the triangles are congruent by the side, side, side congruence theorem. Okay? Okay, so now it says, look at the figure below. Line L and M are parallel, and line T is a transversal that cuts them. Now, it's very important that they disclose that those lines are parallel. You cannot assume that. If they don't say this, you cannot assume that those two lines are parallel. Anyway, this is a click it, sorry. So try this one, hit pause, come back when you're ready. And hopefully you got D. It says, which of the following statements is false? Now, they did tell me these are parallel. Oops. So all of my corresponding angles, vertical angles, all of that stuff is all true. I can use those theorems. So it says, which of the statements is false? A says that angle 6 equals angle 7. Well, that's true because those are vertical angles. Then it says that 6 equals 3. Well, that's true because they're alternate interior angles. Then it says that 8 equals 4. Well, that's true because those are corresponding angles. And then it says that 1 equals 7. Well, that's false because those are not corresponding or vertical or alternate interior or alternate exterior. They're not congruent because they don't fit any of the congruence definitions when two parallel lines are cut by a transversal. So that's the one that's not true. Again, you could stop there, but just to see the other one, 2 and 7, those are alternate exterior angles, so that's true. Okay? There we go. Alright, so now we got some practice problems. It says, line T is a transversal intersecting lines L and M. Notice they did not tell me that L and M are parallel, so I cannot assume that they are. They want us to write a 2-column proof that says 3 is congruent to 6. Well, normally, again, if I knew these two were parallel, I wouldn't have to prove anything. It's already proven because they're alternate interior angles. But I cannot assume that these lines are parallel. So all I have is that angle 2 is equal to angle 6. So I can say angle 2 is congruent to angle 3, sorry. No, 2, sorry. And that's because it was given. So there's my first statement, and you always start with what's given. Okay, so they gave me that. That's always your first statements in your proof, is what you're given. Okay, so now that I know that angle 2 is congruent to angle 6 because it's given, well, now I can say that angle 2 is congruent to angle 3 because whether those lines are parallel or not, it doesn't matter. I'm not even looking at this part. Those are, sorry, I always forget to number my steps. So the reason for step 2 is that they are vertical angles and they're equal. So I've proven that 2 is equal to 3. Okay, therefore, I can say that angle 3 is congruent to angle 6 Not because they're alternate interior. I can't use that reason because I'm not guaranteed that L and M are parallel. But I can, because if angle 2 is equal to angle 6 and angle 2 is also equal to angle 3, then angle 6 and angle 3 have to be equivalent to each other. And the reason is, the formal reason is it says if two angles are congruent to the same angle, and see the shortcut, we don't ever write out congruence or angles, we use the symbols. If two angles are congruent to the same angle, then they are congruent to each other. And so I'm done. I've proven it. Okay? Alright, next we've got, in the diagram below, we know that AB is equal to DE, that AC is equal to DF, and that angle A is equal to angle D. Is triangle ABC congruent to triangle DEF? If so, how would you prove them congruent? Alright, well, it looks to me like we've got side, angle, side. So I would say yes, they are congruent, and what I would go about using if I were to prove them would be the SAS theorem. It didn't actually ask me to prove it. It just said, how would you prove them? Well, I would use the SAS theorem. But let's go ahead and do that. So my first statement, again, is usually to tell me and the one whoever I'm writing to what I'm given. So I'm given that AB is congruent to DE. I'm given that AC is congruent to DF. And I'm given that angle A is equal to or congruent to angle D. And that reason is they were all given. And then pretty much after that, they did the whole proof for you. I can say triangle ABC is congruent to triangle DEF by the side angle side theorem. That would be a very easy proof. It's nice and easy when they give everything to you. Alright, 3 says, given that the measure of angle BCA is 70 degrees in the diagram below, write a 2-column proof that proves that the measure of angle BCD, which would be, let me get a different color here, BCD would be this one, is equal to the measure of A plus B. Well, what I have to do is start with what's given. So I was given that angle B, and I should put the little m for the measure. The measure of angle BCA is 70 degrees, and that was given to me. Okay, step 2, where can I go from there? Well, I can say that the measure of angle, and you gotta label all these because of the, it's confusing when I say angle C, because that actually represents two different angles. I normally just like to say angle A plus angle B plus angle C, but you can't, because which I'm going to cheat a little bit. I'm going to say the measure of angle A plus the measure of angle B plus the measure of angle C, but I can't just call it angle C because C represents two different angles, so I have to use 3 letters. So I'm going to say BCA. Well, that has to add up to 180 degrees, and that's by the theorem that says the sum of 3 angles of a triangle equal 180 degrees. And again, notice my shorthand. Okay, so I've proven that those 3 are 180 degrees. Well, I also know that these 2 angles have to add up to 180, so I can say the measure of angle BCA plus the measure of angle BCD has to equal 180 degrees. And the reason that is because they are supplementary angles. Okay, so now what I can say, interestingly, is, you see how I'm saying that both of this is equal to 180 and this is equal to 180? Well, then by substitution, this quantity, the measure of angle A plus the measure of angle B plus the measure of angle BCA has to equal this box. I don't have room. Darn it. Let me see if I can write smaller. Alright, so we have, I'm going to leave off my little m's here, okay, just because I want to try and write this all on one line because it's easier to see the substitution. So I'm going to leave off my little m's, which is very bad, but understand I'm talking about the measure of the angles. So angle A plus angle B plus angle BCA has to equal angle BCA plus angle BCD. And again, these both equal 180, since this amount equals 180 and these two equal the same amount, so these two things have to be equal to each other. And that is just by substitution. Alright, and now you're not supposed to do the math in your proof, but again, I want to show you why I came up with this. So the original thing I was trying to prove is that BCD is equal to A plus B. Well, it is because, again, and you don't do the math in your proof. What I'm writing in green, you wouldn't actually write on your proof. But what I'm doing is I'm subtracting angle BCA, which cancels out, and what that leaves me then for step 5 is that angle A plus angle B has to equal angle BCD. And that is by subtraction. I subtracted the same amount from both sides. Subtract angle BCA from both sides. And we proved it. Okay? Like I said, and I wrote everything in green, you wouldn't actually do this in your proof. It's just to show you where I got from this line down to what I was trying to prove in the first place. Okay? Alright, so number 4 says in triangle ABC and DEF below, angle C is equal to angle F. And what other piece of information would you need to prove that triangle ABC is congruent to triangle DEF by angle side angle congruence? Well, you know this angle. So if you're trying to do angle side angle, you'd have a couple of choices here. If you did this angle and this side and this angle, then what you would need is I would need to know angle B and angle E, and I would need to know the length of BC and the length of EF. Okay? Or forget this option, I could do this angle, this side, and this angle. And in that case, I would need angle A and angle D. And I would also need side AC and side DF. Either way, I could, if I knew this information or could get that information, or this information or could get it, then I could use angle side angle congruence to prove those two triangles are congruent. In the figure below, name the congruent triangles. Well, what I do is I always pick one triangle, the first one, and I just label it usually alphabetical. And then I figure out what the corresponding angles are. So in this triangle, angle A is between the 6 and the 10. So here's the 6, here's the 10, F is between them, so on this side, A has to be in the same position as F. Well, now I go look at B. B is between the 6 and the 8. 6 and 8 over here, E is between, so E and B have to be in the same position. And then I look at my C, which is between 8 and 10, and over here between 8 and 10 is D. So C and D have to be in the same position. That would be my similar triangles. Okay? Alright. So number 6, it says given two triangles, ABC and DEF, where angle A is equal to angle D, and B is equal to E, and C is equal to F, are the triangles similar? There is no theorem, angle, angle, angle. And the reason is, this could be true, but not always. because of similar triangles. In other words, if I drew, just as an example, right triangles came to mind. Okay, this could be 90 degrees. So if you have isosceles right triangle, you'd have 90, 45, 45, 90, 45, 45. Clearly the three angles are equal, but obviously the sides are different. So because of similar triangles, that's why angle, angle, angle is not a theorem of congruence. It would mean that they're obviously similar, but it doesn't necessarily mean that they are congruent. Okay? That's why the angle, angle, angle theorem does not work. Alright, 7. In the figure below, triangle ABC is congruent to triangle EDC. Explain why. Well, you have, what you're trying to show is that, well, okay, sorry, what I could say is that angle C equals angle C. Okay? Well, if I take this and try and put it in the same position as this, because sometimes it's easier for me to see that, this would be D, this would be E, and this would be F. Okay? So, what you're trying to, the problem here is you know that these two angles, this side and this angle, are equal. So, but that is going to be side angle angle, or angle angle side. Well, those two theorems don't exist. Okay, so what I need is probably angle side angle, and I don't have that because my side is not between the two angles that I know. So I have a problem here. I've got to figure out does angle A equal angle E? I got to prove that so that I can use angle side angle, because all I have is side angle angle, or angle angle side, and that theorem doesn't exist, just like AAA doesn't exist. Okay, but since I know that the two angles in a right triangle are equal, then well, not necessarily right triangle. If two angles of a triangle are equal to two angles of the other one, then the third angle has to be equivalent, because the three angles have to add up to 180. Well, if these two are the same, then I don't care how you add them up. That's going to be the same as when you add these up. And when you subtract the same amount from 180, 180 minus whatever that is, and 180 minus the same amount on this one, is going to give me that angle A is equal to angle E, because you're subtracting the same amount off. Okay? So now I can say that angle A is equal to angle E, because of, if two angles of a triangle are equal, the third has to be. I mean, you could say that better. I'm kind of doing an impromptu proof here. Alright, so now that I know angle A equals angle E, and I know that, I should have started earlier, I know that AB is equal to AB, I had to do it in the right order, is ED. Okay, that was given. I also know that angle B is equal to angle D. That was also given. And I know that, so what am I trying to do? Angle, side, angle. Well, there we go. Angle, right, side, angle. So I can say triangle ABC is congruent to triangle EDC by angle, side, angle. Oops, sorry, didn't mean to switch it that fast. Okay. Alright. So number 8, it says, given that AB is congruent to DE, and angle B is congruent to angle E, and BC is congruent to EF, how would you explain that that angle A is equal to angle D? Well, again, I have side angle, what they gave me was side angle side, side angle side. So I can say that triangle ABC is congruent to triangle Got to put it in the right order. A and D go together. B and E go together, which means C and F go together. So I can claim that by, what do I got? Side, angle, side. Okay? And then once you prove that your two triangles are congruent, you can say angle A is congruent to angle D because of corresponding parts in congruent triangles, I should write out, are equal or congruent. Okay? Alright, 9 says, which corresponding angles or corresponding sides in the triangles below could be congruent but not help to prove that the triangles are congruent? Well, if I proved that, I can prove that angle C equals angle C by vertical angles. Okay? So I have two angles that I know are equal. The only thing, again, like we talked about before, that's not going to help me prove anything was if I had like angle, angle, angle. So what's not going to help me is if I know that angle A is congruent to angle E. That won't help. Not help because that would give me angle, angle, angle theorem, which does not exist. So you would have to establish at least a pair of corresponding sides are equal. You'd have to establish that you've got a pair of corresponding sides that are equal so that you could use angle, side, angle somewhere. Okay? Alright, number 10, it says, given that angle A is congruent to angle F, and AC is congruent to DF, and angle C equals angle D, or is congruent to angle D, are the triangles ABC and FED in the figure below congruent? I say yes. The book says no. And I think there must be a typo because I think they meant to put this in a different order. I'm not sure, but or I'm screwing up. I don't know. Geometry is not really my favorite in the world, but I can't figure out why the book is saying no. In my mind, that's angle, side, angle. So yeah, you're saying that triangle ABC is congruent to triangle FED by angle A congruent to angle F, side AC congruent to side FD, and angle C equal to angle D. That's side, angle, side. So I say yes. But the book says no. And the only thing I can figure out, the only thing that doesn't make sense to me is this order right here. But again, you're saying the length of, when you put that bar over it, you're saying the length of DF. Or, no, do you not have them? I don't know. Anyway, the only thing I can figure is they went AC, and here they wrote, which goes in this order, and here they wrote DF, which goes in this order. But if you're just talking about the length of the side, I don't know. This is correct. This is wrong. I mean, this is technically written wrong. It should be FD, not DF. But I don't know, honestly. I really don't know what to tell you. So if anybody's watching this and can explain that, yeah, send me a note. Alright, so, oh, we're at ACT. So go, try this one, hit pause, come back when you're ready. Alright, and it says, below is a two-column proof that the measure of CBA plus the measure of ACB is equal to the measure of CDE plus the measure of DCE in the figure above. Okay, so we're trying to prove this. Alright, so I'm looking at what it says, which of the following statements must be included in statement 1 so that the proof is complete? Well, I'm like, I have no idea. I got to try and figure out what they're trying to do. So what this says is that the measure of ACB, which is this one right here, is equal to the measure of DCE. Well, that's true by vertical angles. So I'm trying to figure out where they're going now. So then they said the measure of CBA, I'll get a different color. CBA, this one right here, is plus the measure of ACB, AC plus this one, is equal to the measure of CDE, this one, plus the measure of DCE. Okay? And then what that says is that the reason they can say that is when equals are added to equals, the sums are equal. So what I'm looking at is, if you look above in statement 2, they had to go from here to here because somewhere they're adding to equals. So I got to figure out what equals they added it to. Sorry, I'm trying to switch colors. So up here you have measure ACB, which is this right here. And up here you have DCE, which is here and here. So it says when equals are added to equals. Well, we know these two are equal, which must mean that these two are equal because they're saying when equals are added to equals. So what must be missing here is this statement, which says that the measure of CBA has to equal the measure of CDE. That had to have been given for me to figure out that for this proof to make any sense. Okay? Alright, try this one, hit pause, come back when you're ready. And hopefully you got H. It says if you were given that ABC is congruent to EDF, which of the following statements is not known? Alright, for F, I just like to write it out because to me it's easier and I don't write my triangles. I'm sorry, I'm being very lazy. You just check the order. This says AC, which goes the first to the last, is congruent to EF. Is that this goes first to last. That's true. It's the same order. According to that statement, I can line them up. Okay, for G, let me write it again. ABC, similar, or not similar, congruent to EDF. This says angle ABC, that's in the middle, is congruent to FDE. D is in the middle, so that's true. They're in the same position, so I know those two angles are equal. Oops, sorry. Okay, H says, a different color. Write it again, ABC congruent to EDF. H says that CA, which would be third to first, is FD. Well, that's third to second, so that's false. This would have to be F to E to be true. So this is false. And again, that would be the one that's not known, so I could stop here. I don't need to keep going. But again, just to give you a little bit more learning material here. Oops, I use that color. So let's look at J. I have angle C is congruent to angle F. Well, ABC congruent to EDF. C is here, last position. F is in the last position. They match. That's true. And then K, I have ABC congruent to EDF, says angle BCA, that's angle C, and angle DFE, that's angle F, which are in the same position, so again, that would be true. Okay. Alright, try this one. Hit pause. Come back when you're ready. And hopefully you got D. Alright, it says we're given that AB is equal to DC and that EB is equivalent to HC and that BF equals CG. Oh, I missed that before. And that EAB and HDC are right angles. So this is what we know. Okay? Alright, so it says which of the following cannot be proven about the figure above? Well, if I look at A, I'm trying to prove, they want me to prove that AC is equal to BD. They want me to prove that from here to here is equal from here to here. Well, you can do that with segment addition. Okay, I can say that AB plus BC equals AC, and I can say that BC plus CD is equal to BD. Okay, well, I have BC in the same place, and AC is equal to BD. So I can easily say, I can replace BD here. I can replace my AC here with BD. And so now I'm saying that this equals BD and this equals BD. Therefore, oh no, I'm trying to prove that. My bad, I can't say that. Sorry. Equals AC. Alright, so what do I know? What was I thinking? So, what did I do? I'm sorry, I'm trying to think of what I did. CD plus DC equals AC. Well, what was I thinking? I think I used this and wasn't sure. Okay, we'll see how these both have BC in them. So if I solve this for BC, I'd say BC equals AB. BC equals AC minus AB. And if I solve for BC over here, I'd say BC equals BD minus CD. Therefore, AC minus AB has to equal BD minus CD. And what does that tell me? Oh, I know that AB and CD are equal because it was given to me. So, if I can replace, either way, I could replace, let's say, AB with CD. So now if I add CD to both sides, that cancels and I get AC equals BD. Hey, I did it. Okay, so that one I could. For B, can I prove that triangle ABE is congruent to triangle DCH? Well, yeah, I can, because if two sides of a right triangle are equal, oh yeah, that would make sense. If I can't use, like, this would be angle side side or side side angle, which doesn't work. All right, but because of that they're right triangles, because of the Pythagorean theorem, if two sides of a right triangle equal to two sides of another right triangle, the third sides must be equal because of the Pythagorean triples. If those are right triangles, the sides have to make up a Pythagorean triple. Well, if two of them are the same, then the third one has to be. So yes, I can prove that one. For C, can I prove AE is equal to DH? Well, I've got AE here and DH here. And yes, I can, because up here I just said I can prove they're congruent. So that means these are equal because corresponding parts of congruent triangles are equal. Can I prove that EF is equal to GH? Oops. Can I prove that EF is equal to GH? Well, no, I can't, because in order to prove those two are equal, I would have to know or prove that triangle EBF is congruent to triangle GCH. And I don't have enough information to do that. All I know is that I have two sides equal, but I don't know about the third side or any of the angles. So unless I knew, like, these were parallel lines or something like that, then I might be able to do alternate interior angles and prove something. But though they didn't tell me that those lines are parallel, so I can't do anything with angles. I can't figure out missing sides. I don't have any numbers. So that's the one that I would not be able to prove. Okay, and on E, the measure of angle ABE equal to measure DCH. Well, again, I already proved the triangles are congruent. So yeah, those angles are because corresponding parts of the congruent triangles are congruent. Sorry, didn't mean to flip that fast. Okay, so that would be the one that I couldn't prove. Here's my problem with these geometry problems. That took a lot of time to figure out, okay? On these type of problems, if this was a real ACT question, I would skip this and save it to the end. Not because it's necessarily hard, but it's quite time consuming. I mean, obviously I spent way more than a minute on that one figuring it out. Alright, try this one, hit pause, come back when you're ready. And hopefully you got H. It says, given two triangles where ABC is congruent to DEF, which of the following could not be proved congruent? Well, F says that B is congruent to E. Well, I can prove that they're in the same position. G, A, B, C, D, F, AC congruent to FD. Well, that's first to third, first to third. No. F to D would be third to first. And see, this is what made me like that proof that I said, if anybody can figure out what I'm not getting, let me know. Here, they're clearly saying that that doesn't matter. And they put this in the wrong order, but it's the same to, like I said, the length of DF is the same as the length of FD. So I'm assuming that the order that they write the letters in doesn't matter. But because this one, according to the book, this one I can prove, which would be corresponding parts, so that would be true. Okay, for H, it says that AB is congruent to EF. Alright, well AB goes first to second, and EF goes second to third. That's false. They're not in corresponding positions, so that one's got to be the one that I can't prove. For J, even though we don't need to keep going, angle C congruent to angle F. C is in the last position, F is in the last position. That's true. And for K, sorry, I didn't write it down again. You have DE, which is the first to second, is to ED, which is the same line in the same triangle, so of course they're congruent. Okay. Alright, try this one, hit pause, come back when you're ready. Excuse me. Alright. You're given that ABC is congruent to DEF, which means A is congruent to D. So since D is 40, A is 40. That means that B is congruent to E. So since B is 115, AE is 115. And it wants to know what's the figure of angle C below. Well, that's the third angle in a triangle. So 180, take away 115, take away 40 is 25 degrees. So both C and F would be 25 degrees. And we have finished day 7 proofs, which nobody usually likes. So I will see you next time for